Confirm that. In this video, we will cover histograms and group data and learn how to construct and interpret them accurately. Why does this matter? To study household wealth, we group continuous incomes into distinct categories. Although they describe the same sample, the ranges are unequal. How do we visually plot these unequal grouped ranges without distorting the data? First, let's understand grouped data intervals. Continuous values must be grouped into non-overlapping bins. These intervals must touch each other continuously on the axis, but they must never overlap, ensuring every data point falls into exactly one bin. How do we scale bar heights when interval widths are unequal? We use the density formula. We calculate the density height of bar I, denoted as h sub I, by dividing the relative frequency proportion, denoted as p sub I, by the physical width of the interval, denoted as w sub I. This ensures the bar's area represents its true proportion. Let's run worked example 1 for an income bin. For the interval from 0 to 20 with a relative frequency of 40%, the width, w sub I, is 20, and the proportion, p sub I, is 0.40. Dividing 0.40 by 20 gives a density height of 0.020. In worked example 2, we calculate density for sleep hours. For the interval from 5 to 8 with a relative frequency of 50%, the width is 3 and the proportion is 0.50. Dividing 0.50 by 3 gives a density height of approximately 0.167. Now, let's look at the finished histogram. A histogram represents a continuous variable using adjacent bars with no gaps. Unlike bar charts, the borders touch, and the area of each bar is proportional to the frequency of that interval. Now, let's explore distribution shapes. In positive skewness or right-skewed distributions, the long tail extends towards larger values on the right. Household income is a classic example where a few high-earning households stretch the tail. Conversely, negative skewness, or left-skewed distributions, occurs when the long tail extends towards smaller values on the left. A tough final exam where most students score highly, but a few score very low, displays this left-skewed shape. Symmetric distributions show a perfect balance, with mirror image tails extending equally on both sides. Physical metrics like height or average hours of sleep typically follow this bell-shaped symmetric curve. Let's highlight a common mistake. You must not use absolute counts for the heights of unequal bins. Doing so creates an inflated, distorted area. Instead, normalize the heights to relative density so that the areas preserve true proportion. To summarize, histograms plot continuous variables using adjacent bars. Unequal widths require density-height scaling. Positive skewness points to the right, and negative skewness points to the left. Thank you for tuning in to Topical Brew. Keep practicing, stay curious, and make sure you're subscribed with notifications turned on so you're ready for our next topic. If a concept felt a bit tricky today, or if there's a specific challenge you want me to break down in the next video, let me know in the comments.